I can actually see these feeds. Just to remind you, if you have any questions and you don't want to broadcast it to the group, which totally get that, you can message me directly, personally. I will not read out your question. I will not read out who sent it, but the question is often a question that is luring, if you will. A lot of people have that same thought, and it can be nervous to even talk about it. So I tend to read the question out, but not who it's from. So if there is questions as we're going through, please, send it my way, and I will try and answer it. So I've gone on to Blackboard, and I'm onto Advanced CAD. Under Advanced CAD, on Module Materials. I'll just turn that off or else that'll get confusing. There we go. Under Module Materials, Surface Notes, Week 3. 2 sets of notes here. First one is guide curves. Now we're going to be using guide curves in this session, but this set of notes was set up by a member of staff who was my lecturer at the time. I'd always recommend this set of notes because it really teaches you about setting up guide curves. It teaches you about setting up the baseline of all this, which is the skeleton of the actual structure, then creating that surface over the top. For anybody who doesn't know, this is the process that Joel Allison used when he produced the first Shell Eco Marathon car. All he'd essentially done is used these profiles to actually generate it. And for those of you who didn't know, me and Joel were in the same class together because we were at uni at the same time. So the lecturer who did this was our lecturer in this topic. This technique, this example is just one that's made up. But this technique can be applied to noses, fuselage, empennage, anywhere with a particular profile needs to flow between it. It's a good technique to use. For this, I'm not going to concentrate on this because what I want to really concentrate on is lofting. I'm going to download this. Let me just download it, stick it on my desktop. And as ever, I will upload the models afterwards. By the way, I don't know who saw this last week, but I managed to find the problem from the bottle. It actually turned out to be the label and where I'd placed the circle. I did record it, so it is on the recording, and I modified the circle position, and it's just because it wasn't flowing completely round the actual profile correctly. So I modified it, fixed it, and it was running right again. But it was bugging me where that came from, but I did find it. Right, so with 2 profiles that we're going to be looking at. The basic one and the more advanced one. Again, anybody who's followed me already from yesterday's session, if you followed me, caught up on the video, then you'll know this already. This is the problem child, in a lack of better words. For those of you who didn't, don't worry, I'm still going to go through the big asked questions as we're going through it of, well, why is it a problem? Where are these things coming from? So we are going to cover that anyway, but just want to let you know that this is the big problem child. But this one is a nice startup. So anybody who's confident, please, fire away, go as quick as you like. For those of you who know the secret problem, the huge, massive problem in this, you'd be surprised how Inventor deals with circles. It was fascinating to see the difference. But we're going to go through that and we're going to take a look at that. Right, so I'm just going to snap that over there, and let's take a slow work way through it. So what I'm going to do is come on to my part, and I'm going to go part. Yeah, it's just because of my graphics card. So, where I am is here. So I'll zoom this in. I'm going to try and go as dead steady with this. Again, if anybody wants to rush like mad and just do it, you're welcome to it. But for those of you who are not very confident, I'm just going to try and go steady and try and be consistent in what I'm doing. You will find that I don't tend to use shortcuts. The only reason is I would prefer that you guys knew where all the tools were, rather than, because if I use shortcuts, you miss out where the locations of these tools are. But if you know shortcuts, you're welcome to them, honestly. So let's get to it. I'm going to come on to my plane. I'm going to go from my YZ plane, which in this case you could easily call the right plane. So I'll go sketch. And based on this, we have basic profiles here. So I'm going to draw these on because I've got dimensions that are going to constrict it. So what I'll do is, I know there's a line. And I've just realised you can see my units there. Units are incorrect. So what I'm going to do is go to Tools, Document Settings, Units, and Millimetres. If anybody knows how to set that default, you're welcome to telling me, because that's bugged me for ages. So I'm going to go millimetres. Every time I set it, it just seems to bring itself back. I think I'm just cursed. Anyway, so I've gone back to line. Draw a line from there to there. Line from there to there. Line from there to there. A diagonal line here. And then to there. None of it's real, because I still need to do a few things. Now if I come back, I know here there is a midpoint relation on that line. So what I'm going to do is, this is a really cool tool about Inventor that I really do like. So I'll show you. I'm going to go on coincident, at least a concentric. I'm going to go on coincident. Now I can select there. That will just give me my point. I'm going to the end point there, or there. Now with Desalt, you need to define exactly where you're coming from. However, if I move up the line, it'll pinpoint there and automatically select me a midpoint. So it's a little bit of a tool with it, but it's a little tool that I do actually quite like. So that's now got me that line. So all I need to do now is just start dimensioning. So I'm going to go dimension. And with that, I'll set that to 250. I'll set my back line to 40. I'm going to set the rise of this point here to 20. Then my distance between this point and the back plate is 12.5. And we have an angle there. So what I'm going to do, just to help me, I'm just going to drag that across. It just makes my life easier, because I'll go that point to that back plate, and that's where my angle is going to come from. So this angle, according to this drawing, is 9.5. Got a question rolling in. 2 minutes. Have I got a question rolling in? No, I don't. Apologies. Oh, yes, I do. Ah, yes. Now, yeah. Thank you. I tried that, and for some reason, I'm still having the same problem. And I got in touch with them myself, and they said, don't worry, we'll send you an updated template. So they sent me the updated template. It still did the same thing. I think I'm just being stupid with something. It's bugging the crap out of me. But that's some good advice. Thank you, Martin. Right. But yeah, it's been bugging me for ages. I'm going to give it another try today, because I think I've backed up my template on OneDrive, and I think what it's doing is it's reading offline and then overwriting what I'm doing. Sounds crazy, but it's driving me crazy, if I'm honest. Right, so we know from that it's got 100mm extrusion. So I'm going to go 3D model. I'm going to go extrusion. Not solid. Going surface, and I'm going to go 100mm. Confirm that on 100mm, and then we got his plates. Spin it round just to show. So as ever, it extrudes the area that we've drawn, and all we need to do is cap off these ends. Now in SolidWorks we add a planer. In this we add a patch. Now I don't know who's played around with this, who's been getting used to this, but you should start to realise that the beauty of patch is patch is smart. What it will try and do is try and give you a result of whatever it is that you're looking at. Do not double patch, because that's what you'll end up with. But with patch is about the whole and not operation of planar behaviours. So this tool for me wins in the battle between Dassault and Inventor. For me personally, it wins. I think it's much better. But again, still my opinion. So we've got a nice little drawing here. The reason I put this on here, so again, some of you will be like, it's dead easy to do. But what I wanted to do was just do some basic stuff in there to just really wake some of your CAD skills up, if you will. So all I'm going to do is I'm going to sketch on the top and do a sketch. Right, from there, I'm going to do a corner rectangle, bring that down like that. And my first dimension is the distance between these two, and that becomes 20 mil. The distance for the full length is 87 mil. Distance from the top edge to the top of the horizontal line is 6.5 mil. I had to check that. 6.5. And the distance from the back edge here to my vertical line is 10 mil. And like SolidWorks, it's black. We know that it's been full defined. I'm going to click OK. Right, so I'm going to just call this. I'll leave that in there for the minute. So, again, based on these notes, we've got an offset of 45 millimeters. So I'm going to do plane, offset plane, and then go there. So I'm going to go 45. So we've got that offset there. Again, you can't really compare a tool like that to any other CAD systems. They all do very, very much the similar. This is a tool that I'm looking forward to showing you though. Now this, the embarrassing thing on this is all the dimensions weren't put on there, so it's still blue. It's not fully defined, but this will be defined. What we're going to do is we're going to define the whole thing with 2 dimensions and using smart constraints. So I'm on the top plane that I've just added, and I'm going to add a sketch. And what I'll do from there is go a line, construction line, and tracking it to that edge there. I'm going to bring it up to that point there for interface, and then do the same thing on this side to track to that edge, and then bring it to there. So I'm giving it that crosshairs, if you will. Then I'm going to bring in a corner rectangle, and I don't want this to track to anything, so be careful about automatic tracking. Now when I say that, if I bring that over, you'll see that the line wants to locate itself. So I want to make sure that it's roughly... Oh, I forgot to do that. So I just want to remove my construction tool and bring a corner rectangle and draw it straight across like that. Now all I'm going to do is I'm going to go, not mirror. Here I've got symmetric. So I'm going to go this edge and this edge, and this edge. So my left and right by this line. So if I've done it right, what it'll do is it will only operate around that centre as axes, which is useful, really useful. So I'm going to repeat that process of symmetrical, that edge and that edge by that edge. So again, got that restriction there. So this is where you're really able to bring in the dimensions. So on that point there, I'm just going to make that 48.8, which is the dimension, 48.8. And then my vertical being 10.5. 10.5. Now the beauty of this is if you're using equation-based modelling, if you're using any particular special input, a smart input that you've got, one thing that is really great with this is that if you're doing an API program, it will allow you to interface even more, even better. 2 seconds, I had a question. Oh, it's something else completely. So we've now got that constraint around there, and for those of you who are CAD savvy, for those of you who've done a lot of CAD, you'll know that if you have a drawing that has hundreds of irrelevant dimensions on it, you kind of go, God, there must be a better way of doing this. And if you can use that geometry to your benefit and then restrain or restrict as many dimensions as you can, what you're then in a position of is easy modification. Students who are on motorsports, you'll know this, especially when it comes to engine components, car components, any slight modification to a system. One value, 1 micron change to the combustion chamber alters everything. But imagine if everything wasn't properly constrained and you make that micron change. Everything else has a knock-on effect and everything goes bright red and there's errors everywhere. So it's just a matter of thinking smart. That's all that is. So I'm going to close that. I'm going to turn off that plane. And what I want to do now is create a loft between here and here. And we're going to use the trimming tool for the first time. I think we have used a trimming tool. I'm just trying to think how many times. So I'm going to go loft. God damn. I'm going to loft, and I'm going to come from that face down to that face. And that's your initial first. However, let me go conditions. See how we've got these conditions set here? You see here it's actually constrained. If I drop that out and have a direction of conditions, I can go to different states. Now, I did have some students before, not this year because you all seem to have asked really good questions if I'm honest. But some students asked me before, that's great, but what the hell is the point? Where would you ever use that? Now, the most common place I see this used is on manifolds. The idea of being able to control the flow from your lower edge to your upper profile and making sure that you have a normal 2 as it flows between the two is extremely valuable. Controlling the angle that you're operating to. You might not be looking for a normal 2 as far as 90 degrees goes, because as you can see, with the starting angle and finishing angle, you'll see it's holding that 90 degree from the sketch and it's flowing that way. You can edit that to make it sharper or make it wider, depending on which way you're going to go with it. But it's a really useful tool in this case. A really, really useful tool in this case. So I'm going to confirm that. Oh, already made mistakes. That is awkward. So you see there, it's solid. Should have gone surface. It's one thing that irritates me. If I go back here, go on to here, and then you'll go, and then you go, oh, it's a hell of a shame. And then if you try, and you go, oh, hang on a minute, no. So, I know there is a way to actually reset them, but you just think, it's a bit shoddy, don't like that one. So what I'm going to do is go surface, that's an extrude, that nearly got really awkward. I'm going to go surface, choose my profile, and then go back again. Set these to a normal 2 function, so they're operating at the 90 degree from that sketch, flowing to the next, and then if I go confirm, now we end up with that. This is where trimming is vital. So in a surface model, if you cannot see it, then it should not be there. That is the unsaid rule. And I only use that because it's the same rule we were given as students by our lecturer who taught me and Joel. Let me find a good so let me just set that back a little bit like that. It's just so I can show you. If you look there, we've now got a plate there that shouldn't really be there, because technically this is a surface and that is going to be capped off up here. So really, as that's inside, it makes the surface not right. It makes it a large error. Now I point this one out because that is the most biggest neglect I find each year, and this is one of the biggest things that lose students loads and loads of marks, because it's the basic fundamentals of what we're doing. Right, now in SolidWorks we either choose a standard, we choose a mutual, and I know we did a bit of it last week, but this is even more blatantly obvious what we're doing. So what I'm going to do is say trim, and then it comes up and says, okay, what is your cutting tool? I can choose that, but what I'll do is where that's interfacing to the base here, I'm going to use this as my cutting tool. Then what it does is says, right, you've chosen that as your cutting tool, what is it that you're going to remove? So I can pick on the outside, and you can see there, I don't know how well you guys can actually see it, but you can see there that the outside body is highlighted. So if I click it, it will vanish. But what I'll do is I'm going to tip it over, and I'm going to click the inside. And you see there, and then if I click apply, or if I click OK, what we get now is that trimmed away. So I'm going to go back to view, and I'm just going to turn off my half section, and I'm just going to go to end selection just so it's there, and that's what gives me my what is now should be, oh in fact I've not knitted them together, so we're still at empty bodies. It will be a good time to knit together soon though. So finally, what I need to do is close this off. This is going to be one way that I can generate this as a solid component. Now, what we're doing today is we're actually generating solid components two separate ways. One way is this way, where what we're going to do is we seal, if you will, an empty box, and we fill it with volume. The other way is where we generate a profile and then we thicken that profile to a given thickness. Where is this applicable? This could be a full assembly of something, and then we could split this down into separate components. If it's thickening, this could be a bonnet. This could be custom body armour. This could be a mudguard for a motorbike. This could be a fairing for a motorbike. There's many different applications for this. So what I'll do is I'll go patch, and all I'm going to do is I'm going to patch the top and then click OK. This still resides as a surface. If we look up here, we're still in surface, but what I now need to do is bring these together as a separate part. So I'm going to go stitch. So I'm going to select there, because don't forget with outsides, there, and this will give you an update of what you've selected. I don't like to choose up here, I like to choose on in the workspace. So if you've chosen up there, it doesn't matter. So I'm going to select there, and I'm going to select there. So I now got all of them selected, and I'm going to click apply. And then I'm going to go done. Now, before I move on to anything, this is where we end up with clear differences. Now we still have our final surface sections here, but these are now hidden away. These are now suppressed. Now it's offering just this as a solid piece, and you go, okay, that's great. But what if I wanted to maintain this as a surface piece to continue modelling, because I was ending up with millions of surfaces everywhere, and I needed to check the rigidity of the actual design that I was making. That's doable. So all I do, if I right click on here, then go edit, I can actually maintain this. Oh, I've got to actually delete that out. God's sake. But I can actually remove that out. I'll just remove it. And if I stitch it and maintain it as a surface, I can do it that way. So now what I end up with is one surface, and this is that surface I can keep modelling to. But what's the benefit of this? Well, I'm now in a position where I know it's a big silly basic loft, But I'm in a position now where I can present this to my employer or whoever and say, I can make this out of carbon fibre, I can make this out of fiberglass, I can make this out of a multi layup, or I can make this out of a solid geometry. But either way, what I've now got freedom to do is simulate in them two configurations. If I try to simulate with a solid base structure, with a volumetric structure, it's going to be problematic, because the second I put it in, it's going to find problems. And volumes, what you essentially say to systems is, I'm going to let you decide the non-linearity of these volumes based on these equations which already exist. Hence why you use what they call shells. Or we go to direct old school FEA, which is the stiffness matrices is acting equally in all three components. So, but what we can do now, because we've got that working, is I can make edits and changes to things. Oh, that's annoying. I can make edits and changes to things. I can make it a solid. I can make it a surface. I've got the freedom to be able to do which way I need to do. But it's a really useful tool in such a way. But again, if this wasn't closed, if I didn't trim out the surfaces from the inside, if it wasn't basically an empty box, this would not work. This would not knit together as a solid. And part of your assignment is one of the key things I'll be checking that you were planning for. If you don't plan for it, it can lead to failure. Just because why are you spending all that time generating a surface model that clearly does not work? So, any questions on that? Awesome. What I'm going to do is save that. That's just my basic one. So I'm just going to save this as my basic loft. So I'll stick that on there as basic loft. And I will upload that to Teams, and then you can dissect it, take a look at it, and compare. So any of you who were with me yesterday, or have caught up from yesterday, or watched this from yesterday's, you'll be aware of how it was generated, and that the process between the two, there's actually, I don't think there's any difference at all. The only thing that's a little bit different is the lofting, the stitching tool. Stitching tool is a little bit different, but nothing much, nothing major at all. In fact, they're comparable, almost identical. So, I'm going to close that. Or what I want to do now is move to the next one. The reason I moved at a good speed then is just because it's a nice basic way to get going, nice basic way to look at it, and the normal twos which we generated. Now what I want to do is move on to this one. I want to move dead steady just with this because it can catch you out. And again, I don't want to put anybody in any awkward scenarios. So I'm going to go dead steady with it. Again, if you're CAD savvy and you're very confident, go as quick as you like. I honestly don't mind. But this is just to help those who are really just getting used to everything in function. So, what we're going to do is set up the base path. So I'm going to go to my base path. I'm going to go to part. And I'm going to go to my XY. And I'm going to go sketch, sorry. I'm going to go start. So I'm going to go line. I'm not using a center line, I'm using a construction line. So my first construction line. I'm going to repeat that 3 times. Make sure I locate from the datum. And do the same again. Until I've got this fixed, I have to change my units again. And then what I'm going to do is go sketch, dimension. Now my actual sizing is 130 millimeters. And I could mess around with adding them dimensions on, which I have done on here, but there's no real need to. I'm just going to make them equal. So I'm going to go the equals tool, equal, 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 and equal. Then what I'm going to do is go dimension from there to there. This is now 120 degrees. We'll repeat that same process coming from the other side, and what I'm going to do is make that my 100 degrees. I would recommend that you try and get that right, just because if you do these backwards, it can be very confusing, very confusing. So if you didn't get it right, please try and get that right. To make my life a little bit easier for negotiating this, because it does get a little bit confusing, I'm just going to rename these. So I'm going to call that center path. Now on here I've added 2 tangent arcs. Oh no! Oh, I nearly took you on a wrong road here. I like to stick with the notes because you've got this and you know the path I'm following. Just in case you kind of think, where's he making this up from? It's just so that you know that I'm actually following something that is predefined. So what I'm going to do is go plane. This tool is amazing in all functions. I praise this tool so much, you guys will have got used to it. This wasn't always here. So using this is so good. So I'm going to go curve at point. This does not have to be on a line. It can be on a spline. It can be along halfway through a spline. It's really good. So I've selected the line itself. I'm going to come to the end point. Boom. I love that tool. Again, I've had a lot of students go, wow, you don't get out much. It's not that. It is just so cool. Anyway, so I'm going to go plane. I'm going to go normal to curve. I again will select that line and then come to the end of the point. And the amount of times you struggle trying to get geometry in position, and you go, what am I going to do? And this just makes life so much easier. Tell you, spoiled. Again, I go in line to the end point. And now we've got the plane 1 with plane 2 and plane 3. Just to make sure that you've got confidence in me, plane 1, plane 2 and plane 3. We're in that configuration. So, as I said, we're going to do some tangent arcs between it. What I'm going to do first is go, oh, let me bring that back, and we're going to go to my XY plane. XY plane, I'm going to do a sketch. I'm going to do an arc from, which way points are we going here? We're going all the way from there. So what I'm going to do is just take, it's not picking up on my line, which is a little bit irritating. So if I come down, you see it's not really locating itself. It's just making it central based on the datum, which is not good. I need these to be interfaced. So all I'm going to do is go to project geometry. For the construction line, that one, that one. I'm going to go 3-point arc from there. Oh, you know what I've done? Oh, I'm going to select there, and I'm just going to change that. There you go. When in doubt, cheat. I'm kidding. Right. So what I need to do now is make these tangent. So I'm going to go tangent, come from this line to that line, and makes it fully defined. You can tangent the other side if you wish. It doesn't really matter, but that line is there. So I'll click OK. What I'm going to do again is I'm going to go back to my XY, put on a sketch, and all I'm going to do at this point now is repeat that same process. I'm going to go 3-point arc. Oh yes, of course. Because it's not related. I do set my stuff not to be related. It's just because I use this for my research as well. So some of you will find when you turn it on, it's automatically related. I turned it off just because of something that I'm doing. So I'm going projected. I'm going to take that construction line and take it from there. And I'm going to go 3-point arc onto there. Ah, forgot to change that one. So what I'll do is go projection, that side as well. Turn that off because I nearly made that fundamental mistake. From there to this point here, and then put that into position. And what we'll do is go tangent along that arc, and that line and that arc. So now that is what you should get. This is the sketch path, got the planes, and we have the arcs. Now the minute the centre paths, that centre path is actually not needed for the minute. So what I'm going to do is come out of there and just hide my centre path. So I'm going to hide that centre path now, make it turn off its visibility. This is only on here because I've taken it from the centre path. So you'll notice there it's highlighted there and also on that side. However, these arcs are needed because these are going to be the central flows between each place. So again, I do like to be quite keen to stay with the notes. So this is on plane 1. If you're unsure about where your planes are, I'm just going to select on plane 1 and then I'm going to do a sketch. Add a circle coming from that datum all the way out, and this has a dimension of 135 millimeters. And all I've done here is I've trimmed this in half to there, like that. So then what I'll do is I'll go to trim and trim there, like that. Come out that sketch. Wow, I'm confusing myself there. There we go. Lost a bit of my bearings then. Now, onto plane 2. I'm doing a corner, I'm doing a midpoint rectangle, so I'm going to go on sketch. I'm going to go to my rectangle, just put it on there. And what I'm going to do is use the technique I was showing you earlier. So if I go to coincident, track along the line to find that midpoint, bring that to the initial datum, and now we've got what we're after. So if I bring this in, got that freedom of motion right there, happy days. So I'll go 75 mil on here. And then what I'll do on that point there, I'll go 45 millimeters. And then okay. Now that's concerning me. That other line isn't defined. I just want to find out why. Ah, that's why. It's not actually locating itself. Just for completion, I want to make sure that it is, so I'm actually just adding that on. Not sure why that didn't. It's probably because I didn't track it correctly. But I've just added that coincident in there just to make sure. Right. I'm getting a little bit out of control here. There's so much there that if I wanted to trace back, I wouldn't be clear. So I'm just going to quickly name some of these. So I'm going to call this tan. Call this tan L. Select there again. Call this tan R. I'll call this circ. And this I'll call rec. It just means if I need to come back, I know which ones I'm looking at, and I can trace them in, track them back very quickly. Right. So finally we have an ellipse. This ellipse sits here, and we're going to sketch onto there. And if I go circle, I've got an ellipse tool here. So I track it from that datum. See, that's what didn't happen earlier, but track it from that datum, bring it from the center, and then just bring out my ellipse. Now, what I'm going to be in a position to do is just come on from that point here and here. See, still not done it. Still not done it there. But anyway, I'll fix that in just a second. I'm going to trim that out. And yeah, it's still. I mean, if I pull that down, that's really annoying. Might be because of some of the turn-offs that I did. So I'm going to just add that midpoint on again, like that. It's not too much of a issue. And what I'll do is do a dimension from there. This is now 100 millimeters. And then we have a rise between here to here. Ooh, it's not giving me that midpoint there. That's very frustrating. Okay, not an issue. So what I'll do is put on a line from a construction line, and then I will push that and track it directly onto the line. So then, if I add a dimension on there, I'm going to go 35 millimeters. Right. One second. Oh, it's not there. Right. So we're now at the next phase. We're now at a position. Oh, I have not added. Oh, apologies. I've got a question rolling in. I think. I keep getting questions that have nothing to do with this session. Let me just check on the main feed. Yeah. Yeah, I keep getting questions from other groups and other projects. What I'm going to do, rename that ELL ellip. So I know my key points here and what each thing is for. And all I'm going to do is I'm going to use this as a rail. Now they call this system a rail. So you think you're going to take it from here and it's going to slide into this direction. So what I'm going to do is go loft. Choose this as a profile. Choose, oh, I nearly made a mistake. Apologies. I'm going to loft again. Surface. Choose this as a profile and choose this as a profile. Then what I'm going to do is go add a rail. I'm going to add that as a rail. And then click OK. Plane 1 and plane 3 I'm going to hide. Oh no, plane 3 I'm going to hide because now that has become obsolete. This, we really need to keep these two active just because we're now going to use the other side. Right, 2 seconds. I've just something slipped my mind. Right. Yeah, this is, for those who followed me yesterday, you'll know why I paused for a second then. I'd totally forgotten about the processes for splitting. So, now, this is where the real discussion starts to come in. We've got a circle. It sounds the silliest of things. What I'm perhaps going to do is first set up the most accurate drawing that I can. And in this case, what it actually ends up being is it ends up being this circle. The original circle is the most accurate tool that we can use for this. But I'm going to show you why we need to create a new drawing. So if anybody's looked at the notes and gone, well, why am I creating the drawing again? I want to show you. So I'm going to go loft. Oh, don't follow me on this, by the way. This is just to show you why we're doing what we're doing. So if I go loft, come on to that. I've had to turn the sketch on so at least I can see it. Choose that as a sketch, and I'm going to choose surfaces. Sorry, I'm going to choose that as a sketch, and then what I'm going to do is add another drawing onto there, and then I'm going to go that one, And then I'm going to add my all important rail onto there. Now, this is the discussion I was having with everybody yesterday, and if you caught up, you'll know about this discussion. See where this flows? See how this moves? Now, when entities are trying to translate to each other, when it's on here, it's a direct flow. An ellipse is just a modification of what the circle is. It's an added spline representation within the two relations. So you don't get any changes. It will flow easily. You end up with two major entities, your lower line and the 3-point arc to give representative. However, what if you're going from a lower line to a 3-point arc to a 4-point entity within a geometry? What you end up with is a system saying, right, the best thing I can do is to try and match the flow from there to there. Which is fine, you know, it's very, I mean, to be absolutely fair, you must admit that it's very clever that it can do that. The process that it can do that is very impressive. However, what if you're needing to be well aware, what if you're needing to know about what's going on? What if this angle here needs to be that all-important micron less? What if you need to be able to control how these two flow together? The only way to really do that is to split these entities. In essence, turn them into three-point arcs. So what I'll do is I'm just going to come back out. I'm going to go back to this sketch. And I'm going to go sketch. So what I want to do now is I want to, in essence, convert the entities. For those of you who are thinking of SolidWorks, I'm going to convert the entities. I'm going to come back out, because now I've done that, I'm just going to turn this off. So this now becomes that drawing. Now, you must admit, I mean, I don't know about you guys, but for me now it starts to get a bit confusing. You've got a loft and all everything starts to move in all different directions. And again, this is only a 2-point relation. But as we move further and further through this, it will go from 2, you may end up with 60, 70 interfacing and millions of surfaces everywhere. So what I'm going to do is simply turn that off for the moment. So I can put all my efforts into these two relating to each other, which I guess that's really odd. So I'll call this mod rec. No, mod circ, sorry. So it's just my modified circle, and I'm going to edit. So right click, come on your swine, edit that sketch. Now what I was just checking is, totally forgot how to split the entities. So on here I kind of went, how the hell did I split them entities? I couldn't remember how I did it. And then, yeah, you look at modify and then you've got split. So what I'm going to do is I'm going to split it there. Let me come back on here. Split. This is what was bugging me. Ah, right, yes. So I'm going to come on here. Can I do it on here? Now... Okay, yeah, whatever. So now what I'm going to do is come on here and go there. And then I'm also going to go there. Now these I'm randomly putting on. So I'm going to split there and there. So now I should have... Oh yeah, I'm making this a real ball ache at this point now. We've got split. Yeah, I think I'm going to have to remove the relation. Really, what I should have done is added that 135 on there. And now if I just trim these away, oh, I've lost that split, that's awkward. So I'm just going to make sure that's a split there, it's better. So then I'm going to trim. that point to that point, bring out that point, and then make it not what I was after. That got very awkward. So dimension type, I'm going to go arc length. I'll show you this again. Now, this is one thing that I was getting myself confused with. When you do, what you can do in SolidWorks is you choose these two particular points, then choose the length, and that will give you an arc. Now, if you look there, that is not what I'm getting. I don't know if I can do it from there. I can't do it from there, but I'll show you. This is why I was getting myself mixed up. So let me just get rid of that. I'll show you again. And what I'm going to do is go dimension. And some argue that this is a better way. I mean, in many ways I can see what they mean, if you know what I mean. You kind of look and go, yeah, it's not a bad shout, that. So if I right click on there and then go this bloody thing. It's not playing ball with me today, so I've got dimension type, and that's what I was just looking for. So that's how I've just changed it here. Let's try that again. Dimension type. You all saw me then, so don't judge me. I'm going to go arc length, like that. And then this arc length now on these is 35 on each side. I think it's worth putting on that overall dimension, by the way. Just to lock it in, so at least now that split I can change with the arc length. So this now is 35, and again this becomes 35, and that now should allow me to create my flow of these four key components and control what they call the drive between the two. So these key point drives allow me to flow between each point. Now we'll find out if that works, because what I'll do is I'll attempt to loft between it. So what I'll do is I will go loft. I'm going to go this sketch through to, oh, I nearly made the same mistake again. So I'm going to go surface, this sketch to this sketch. Now this is what's interesting. If I now go to rail, put on the rail, what you'll notice, come here swine, can I even get that? Yes I can. What you'll notice is it's not made a change. You kind of go and go, well, that was a lot of pointless crap. Why the hell have we done that? So if I go to transition, what I can now do is start to add my transition points. So drop my automatic mapping. That's better. So you see there, we've got, if I highlight, let's have a look. So my mouse keeps dying on me. Oh, there we go. I go back and go to set 2. You can see the arrow flowing. I'll try and do it again. Set 3. See there, it's coming on there. So what we're going to try and do is locate that to there, and then if I go, this can be a real pain in the backside to get it working as you want it to, but what it allows allows you to do is track to them positions. So I'll go, come back, and go, okay. What we see now is we've got a flow there. Arguably, I could move that by editing my transition from the start. I could change that by editing my transition from the start. But by putting in a dimension onto it, it allows me to locate to a position. This process of transition is automatic on SolidWorks, however, is not on CATIA. CATIA needs to be driven as well. So it's strange, different approaches, really strange, different approaches, but that's a common one. So what I'm going to do now, I'm done with my planes. I'm going to turn my planes off, and I'm going to bring in my other surface. So this is what you should be getting. So I'm just going to rename this to remind myself what it's going. So I'm going circ. No, you swine. Going circle to ellip, and then I'm going to go circle to rectangle. So circle to rect. And it just allows me to at least trace backwards. So if I click there, I know exactly what it's doing. Right. So this is where it gets that little bit, even more confusing. It doesn't. This is just as confusing as everything else. That's not what I was after. Right. So what we're essentially going to do is we're going to trim these areas out. Now, if anybody's already done this, well done. Hopefully you've spotted these errors, and hopefully you've spotted where this occurs. So what I'm going to do is I'm going to start trimming things out, and there's a lot of key things that you're about to learn in this next step. As I said, if you followed me from yesterday on SolidWorks, you'll be aware of this already, but it's interesting to see how this company deal with this problem. So I'm going to go trim. It asked me for the cutting tool. This is like what is our standard trim on SolidWorks. So I'm going to choose that as my cutting tool. Then what it's going to ask me for is points for removing. And if I go remove sections, so I can either go left, I can go right, choose whichever way I want to go, and I'm going to go left and take the base away, and then go OK. And then I'm going to go trim again. What I want to do now is use this as a cutting tool. It asks me what do I want to remove, and I kind of go, oh, I want to do it. Can I? Do I remove that? Do I not? So if I click OK, you go, sweet. Oh, you go, oh, hang on. Oh, oh, sugar. So if I go back, I'm going to go trim. We go remove. Can I remove that out with it? Can I be that cocky that I can get rid of that? And go OK. You go, wow. Got a nice flow between the two. Now, what I'm going to do, please do not follow me in this. Do not follow this process, because I'm going to actually put these backwards. If anybody saw SolidWorks yesterday, you should be amazed right now, because when I did this on here, I was like, oh my good God, that is amazing. It blew my mind. I just did not appreciate how well Autodesk could do that. So what I've done is gone backwards, so I'm going to go remove. And again, I'm just flipping this round, so I'm going to remove that side. Okay. You go, oh, sugar. So I'm just going to delete that out. And I'm going to go trim, use that as a cutting tool. And now I'm going to go remove on that side, or that side. But if let me just try it again. Is that, well, I don't, what the, oh, if I go OK, you go, oh, right, that's really weird. Right. So, what this system does is it uses some of their now this is a really nice way to show you actually. If you look here, see how we've got these flowing between the two? This is because of the lines that we'd set up. Now what this system will try and do is be vigilant between the two. It uses not only geometric referencing, it also uses NURB based referencing. This is a double way of being able to step outside of the geometric database. This is why Autodesk are so good with circles. Now, you've heard me talk about circles. It's never been 100% clear what I mean, and what I'll quickly do is I'm just going to hide these because I want to show you what I mean. I'm just going to turn them off for a second. Don't follow this sketch, just to show you what I mean. If I click on sketch, right. Now, I don't know who's ever heard of the geometric database. Sadly, I don't think there's any of you in this group who are old enough to even remember the old school snapping tools. You'll know the snap tool. Everybody knows the snap tool. It's like a grid. So if I go snap tool CAD, so this is quite nice. I can show you what I mean. Let's see if we can get a nice image. God, even these look really sophisticated. We just need a... this is not bad. It's not really a CAD tool, but let me just go open image. Not the best example, but you see these spots between. These have distances between them, okay? Now, each graphics interface has a resolution between each point within it. This resolution interface is what's known as a geometric database. In other words, there is only so small that a CAD system can actually recognize how small something will be. Its subtraction between the two can be problematic, because what you end up with is, if you end up with something that's dead simple like this, where you've got a simple line and you say, right, between there, that's fine because it's just a straight line, you can just cut it off. However, what do you do when you've got a 3-point arc? What do you do when you've got a circle? So, for example, just bear with me on this. If I draw a 3-point arc and then I put a 3-point arc there, then if I put a 3-point arc and I put a 3-point arc which is off that side, what we end up with is we've got 2 points here, but we've got this going on. This is all over the place. What do you do? How does these systems deal with it? So what we've got is we've got a resolution where the system is not clear. Now, anybody who's used Dassault systems, this is not a dig at Dassault, by the way. This is just some of the little bit of nitty-gritty bits what starts to make these two systems different. If you're dealing with micro changes on Dassault, what you'll actually get is zero reference interface. You all must have come across it. When you draw something and it says you'll be creating a zero reference interface, and you go, brilliant. The hell does that mean? What it's actually referring to is that, let's say this line that I'm about to put on here is the obvious reference to our geometric database. What it's saying is anything beneath here doesn't count. So what the system does is it tries to just say, oh, that looks like a big bit, I'll get rid of that. That looks like a little bit, I'll get rid of that. And keeps trimming it down until it gets something. Now, what this can end up being is little tiny surfaces floating in space. These little tiny surfaces are needle surfaces, and they're an error in the subtraction between two component sets. How do you deal with it? You don't. There's not much you can do. All you can do is be vigilant of it. Somebody said to me yesterday, but what if I just ignore it? What if I just generate it anyway and get the part to thicken? Yeah, you can do that. You can do that. If you go to print it, the system's going to go, what the hell are they? Because it registers that there is something sitting there. So what you've got to do, what you've got to do is be vigilant of trying to tidy these things up. So the reason I like this set of notes in particular is really because it heightens some of that problem. So I'll bring back my surfacing. So that's my tool again. Now, I would, if you do get a chance, if anybody's really interested about this and the fascinating difference between the two, I would 100% recommend going through the SolidWorks example, you will be amazed. Absolutely amazed. I was amazed. And I mean, I wrote these notes and I wrote these to have, I mean, you can see here, what this has done is it's created a really big interface here, but it's done it so you've got a direct subtraction. And it is fascinating, absolutely fascinating, that when it comes to circles, this system seems to do so well. So what I'm going to do is go trim. Going to use this side. I'm just doing the process that I did before now. I'm not doing anything specific. I'm going to remove that section. Going to go and that section and go OK. And now we've got that smooth interface across. I don't know who's noticed this, but I did this just to be a pain. We didn't really need to add these. If we'd have removed them completely. If we remove them, you know, the reference between this circle to that point gets so much easier, and it does between here. But I've added it in because you won't always be in that position of being able to do that. It's not always going to be nice for you, and I wasn't trying to be difficult, but it's just a nice thing with it. So all I'm going to do is just delete them faces right out. So let's go on there and delete that, and click OK, and then I'm just going to delete another face of that one. Bring that face in. Get rid of that. And what is a good way to see if you've got any illegal surfaces? Boom. You have these two going on here. If there is any illegal surfaces in your system, you will spot them straight away. And it's always worthwhile just checking to see if they're there or not. But in my case they're not, so I'm good. I'm ready to move on to phase 2, which is now bringing these together. Now, because of how I've been trimming away, I don't even need to consider knitting. The actual subtraction process brings these surfaces together. It's really useful. It's really cool, in fact. I say cool like I'm cool. So I'm going to bring back in. I'm just going to relate back to my 25s and my main 55. For me, this never works out right, so I'm going to go fillet. And I'm going to just change that to 25. Now that edge there and that edge there. Then I like to confirm it. I know you can do double, so I could add that in and then I could add another one over the top. But I like to confirm it just because I'm not used to all this new age stuff. So I'm going to go fillet. Then on there, I'm going to bring that up to my 55. Click on that. Come on, you swine. There we go. Has that not knitted that together? That's not looking knitted to me. Yeah, I don't actually think that's been knitted. I'm just going to delete that back out because I'm not convinced that's been knitted properly. So I'm just going to stitch you and you. Oh, it didn't merge it. I'm going to maintain that as a surface, obviously. Click apply and then done. Right, so now we're stitched together. We've now got to that single. That's better. Oh, naughty. So I'm going to go 25. There, and then I can add another one. 55. Up that means spout over the top, like that. And then OK. Yes, I know, I just broke my rule. So now we've got, and now I nickname this the manifold. It's not, it's not a manifold. It's just when I first drew it, I kind of thought, ooh, that's a manifold. It's not a manifold. Right, so I'm going to come back. I'm going to go to my XY plane. From my XY plane, I'm just going to put on a plane of 100 millimeters. 100 millimeter offset, I should say. So I'm going to go 100 mil offset. Click OK. And that's now going to be what I call the flute position. Come onto that sketch, click on sketch, and now all I'm going to do is put on a centre line I'm going to track it from that position. You can go all the way down, to be honest, because I'm just going to just close that for a second. And when you look at it, you kind of go, yeah, it's not. It's actually just relating to the offset between the two, and that it must be symmetric based on the corner rectangle. Now, yeah, I've had people draw this with loads and loads of circles, and don't overcomplicate things. If it's symmetrical, don't overcomplicate it. So I'm going to go corner rectangle, draw that on. Oh, what a douche. I'm going to remove my center line. Going to go corner rectangle, draw that on, got that on like this, and all I'll do with this now is make that and that relative to that, and all I'll do is go dimension from my my back end. Now that irritates me, I'll just change that. If that comes up, by the way, right click on it and go to, oh my good God, it keeps happening to me today, it's just really irritating me. Right click on it and is that not straight? That is straight. Okay, let's try that again. Dimension, there to there. Right click, linear. Should have done it when I first did it. So it's linear dimension. Going to go 70 millimeters. Bring that in. I'm going to bring that down, and that's going to be 65 millimeters. 65 millimeters. And then my distance, because this is now symmetrical, that distance between there to there, keeps doing that. Now right click, go linear dimension, and I'm going to make that 27.5. And then the easiest solution with this now is just simply add a fillet. Fillet the whole edges, and these fillets are 12.5. So I go that edge, oh you swine, that edge, press Control, and that edge, and that edge, and that edge. Okay. So a way to speed that up, if you press Control, select the edge, it will apply it, you can just click as you're going around. So now that is my, as I said, what I call my flute. 65 by 70, and we're ready to now extrude this. Now this is an extrusion of 5 degrees outwards for a draft, so I'm going to go extrude of that profile as a surface, return that surface, up to next. We're going to go more, and we're going to go a taper of 5 degrees. And just to check, because we're looking for this to go outwards, which it is going outwards, click OK. And now my plane, I can turn it off. And what I will do is go trim, use that as a cutting tool, that to remove, and then click OK. So now you should have a complete open part in such a way. So finally, the thing that I want to do is add my 12.5 fillet on here. Now this was irritating me before. What I'm going to try and do is do a face fillet. Be nice if we can get a face fillet working for this, because this is just yet another thing that we need to get really used to getting doing. So what I'm going to try, that was the wrong button. What I'm going to try is go fillet. Now we see how we got edge. This is a 12.5. 12.5. Now I'll bet you it's not going to allow me to bring in that edge. It won't. So what we've got is we have a face fillet. So I'm going to choose this face, and I'm going to choose this. Oh, yeah, it is on there. This face. So I'm going to go 12.5. Now this is a little bit confusing, so I'm going to try. If I butcher this expression, I do apologise, but it's quite an odd thing to try and describe. the way that the face fillet operates is sometimes you are going to be in a position where you won't be able to knit the two together, but you do still need that relationship to function. What you're essentially wanting to do is to grab each face and then in essence think of them as say paper, and you want to actually create a curve between the two. What you're trying to do is actually bend the two outwards into that correct face to make each face tangential, if you will, and that's all the system knows. The constant fillet is obviously what we've been used to, but a face fillet, the exact same methodology, the exact same functionality is in both systems. This, I can tell you for sure, this is a tool that you would be expected to see in any CAD system that you'd be told to use. You would expect to be able to find a face fillet with a constant. The fillet function should be almost identical in all. But obviously they can have the name slightly different, but the actual execution of it is the same. So if I click OK, what we got now is, interestingly, look above, that face fillet has brought these together. It's knitted. It's already, well, not knit, I shouldn't call it knitted in Inventor. It's stitched. It's already been stitched together. So let's just take a last look around. Everything's sound, everything's fine. What I now want is this to become, I forgot how thick it is. We're going for a 5mm thick internal material thickness. So that's where we're going to thicken it. So I'm going to go to thicken or offset. I want it to be 5mm. It wants to know what profile I'm going to choose, so let me just bring that across, select there, and select the whole deal. Which way are we going? That's going out, that's going in, from face, and I'm going to go OK. Always one. Okay, so what I'm going to do is just stitch. Am I going to need to stitch? No, everything is there. So try this again. Yeah, they're all there. I'm just clicking through to see where the problematic faces are. Oh, we have a dodgy one there. Something wrong with that face. Oh, that's it. That is it. Oh, no, there's not. So that's been more brought in. Thicken 5mm. Why that's died on me. Let's have a look. Oh, hang on, what's that? Just looking around it, I'm having some issue somewhere because it's not. Oh, look at that! Oh, the swine! Oh, what a swine! It's actually, it's actually, oh, it's a needle surface. I did not see that one. Oh, that's embarrassing. Let's delete that one out. Click OK. Now, what that one's doing is when it was thickening, it was thickening, and then the system's going, that is so tiny, you're an idiot. Oh, that is, oh, let's see. I'm just going to select the edges, because one way that I did find before when I was, because obviously we have these problems emerge, especially if we're doing anything that's proof of concept. You kind of look and go, I just got to keep looking to try and find problems. Right, so let's give that another go. Let's see if that'll do it. It might still have errors there. Oh, that is a swine. Oh, right, okay. These are little illegal surfaces just around these edges. Oh. 2 seconds, everyone. Let me just let that dog out. Come on. And everything was going so well. Let's just have a look. Now, yeah, you see there? There's something there as well. So that makes me think that it's actually going to appear on the outside. Oh, you swine. Let's see what bodies we've got active. Right, so there's a few things I can try. I can try repairing that by deleting and patching. So let me just see if I can delete. We'll go heal. That face. Oh, that did not go to plan. Let's bring that back. Oh, that is not what I was hoping for. Let me go delete that. So let's go back. I'm just going to go back to my original trim. Can I edit these features? Let's have a look. So we've come in here and the remove tool. Just see what that does. Cancel. Okay, so that one is doing more than it can. So edit feature. See, it's this area here that's causing all the problem, and it's that resolution. Swine. So that's out there. Let's see if we can pull it on this side as well. Okay, so what I'll do now is go again. I'm going to go now, because I know that my error is coming from that particular point. If I go to thicken, there and there, this is where my problematic areas are. So let me just apply that, see how we get on. So that's now starting to thicken, which is good. So it means if that area is thickening, it means any problematic areas there have probably been resolved, which is always good news. So if I spin it round and then come onto this side there and there, and then just click OK. Ooh, so we have an error there somewhere. Oh, that's a very odd one. Never come across that one before. Okay, so let's edit that. Edit feature. Let's come back and go select. so what I'm going to do is I'm going to try just deleting that. What I'm going to try and do is just removing these for the minute, because what I want to look at is if I just remove my fillet completely, I'm going to try knitting these together and see if that gives me a better outcome. So I'll obviously maintain it as a surface, apply that, and then close, and then I've still got that problematic surface down here, so I'm just going to zoom right in there. And I'm just going to get rid of that one, so I'm going to delete that face. Yes, delete that face, because I know that's a problem. That shouldn't be there. It's problematic things that are there already. So then all I'll do there is add on my constant fillet. I have 12.5. And then go OK. And I'm going to see if that's going to give me a better finish. Where are we coming from? Ah, there we go. That is an odd place to be. I won't lie, that is the very first time I've ever had that issue arise. Oh, hang on a minute, I think I know where that's come from. Oh, I think I know where that's come from. Remember on this fillet? Remember on this fillet, I added that onto there. It's, yeah, I'm going to pull that out. I'm just going to have to modify that, and then I'm going to just get rid of that, and then just checking 1 minute, because this is me rushing them parts, I think, but I'm interested as to find out if that was me. Please don't thicken. Oh no, it didn't thicken. Still having that problem. So I'm thicken there, gone to there. Okay, let's just find out where it's coming from. Why are these two related all the way down? Oh, that is awkward. Oh, that is awkward. Delete that. I'm going to delete that. Probably going to delete all that as well. I'm just going to actually delete that out. Delete. I'll edit that feature. Let's have a look. The reason I'm doing it is there is clearly something there that's not played ball like I wanted it to. What I'm going to do is I'm going to rebuild that over on this way. That's really caught me off guard again. I feel like a reoccurrence of last week. So I'm just going to put on my 25mm and I'm going to quickly change that over. So I'm going to change that to a constant there and a constant there. And then go OK, and then I'm going to just do a fillet, but I'll do a face fillet this time and see if my face fillet will fix that issue that I'm having a problem with. So if I choose that place and that face, and I'm going to 55, 55, and obviously my pull direction here is it's bending the wrong way, so what I'm going to try and do is flip that out. Still not bending the right way. Okay, so let me try that face and that face. That has not played ball with me at all. Right, so it appears it must be coming from that area. So what I'm going to do now then is try and stitch it together from that side. So if I stitch that, apply it, so look there, it's still got this gaping repair between it. That's not good. So I'm going to set that to a 0. You might have a complaint with that. Coming from that edge, which is really odd, because what I do is I try to produce a replica to make sure this is going to work, and that has just caught me off again. So annoying. Now I'm not going to combine, I need to stitch these together. So hang on a second, let me just drop this fillet, delete that fillet, and I'm just going to replicate that process. So I'll go to my fillet, I'll go the 55, see if I can get this to actually do as it's told. Onto the second face on here, second face. That is not plain ball either. So let's try stitching that between there and there, and then maintain. Maintain as a surface. 2 seconds. Yeah, no. I mean, it's a good point about it, but it's really strange. I'm going to show you. I'll show you my. Well, no, I won't. I want to fix this. Let me go fillets. I'm going to bring that back in, and I'll try and bring a 55 up, because obviously that problem was actually coming from there. So I'm just curious as to if that was caused by this fillet, the way it's been applied, or not. Now, the beauties with this going wrong, or right, whichever way you want to look at it, is this is the type of stuff you're going to be expected to do on your assignment. So I'm going to drop that to 25, just to examine exactly what's going on and why. So the thing that makes me curious is this point here. See where it actually comes in? I think that gets to such thin resolution, and I'm not sure what's different on that one from the one that I've already predefined, and I'm really curious to know why, rather than just saying, yeah, because it does. So if I click apply on that, see, it's still coming from that area. Now what will be interesting is if I drop that 55, so if I just drop the 55 completely, so if I, well, I'll just delete it out, and then put on that mid over here as well. Hang on. Oh, look at that. So let me just go back to this stitch, edit definition, maintain as a surface. It's almost like it didn't stitch it. So let me just thicken that. So take it out to the 5mm thickness, and then click OK. Now that brought it in, but that's without the 55. So yeah, that's fine. It's just because it's complaining at the back end. So if I just go back to this and delete that out, I go back to this and delete that out. Now the interesting thing is with this is if I thicken that component now, bring that in, thicken it, and then click OK, what it should do is still have an issue across that back plate. That's a really odd one. So that would suggest that the loft itself was problematic. How is that so problematic? So I'm just going to look at my loft. Faces to there, click OK. Okay, so bring that home a little bit. Let me just click on here. That's better. How odd. So, in true dodgy style, this is the plate that I'm looking at. Now this is what's fascinating me. Now I'll show you this. I am going to fix the other one because that's bugging the crap out of me. So the thickness on that does come in at 5mm, and the frustrating thing is we're looking at a very similar execution. So if we even look at my fillets, what I did is combine the two. There is something there. Okay, there is something there. So let me just come back. I'm going to go fillets. It had to be something. So 25 and 25. And then if I fillet, so this is a 55, isn't it? Yes. So if I go 55 there, that passes up to there. Now that's passed to there. Click OK. You see how this is a nice flow between it. There's no consent. There's no problems with it. So let me just quickly check this. Go internal and click OK, and then that should please thicken. Oh, you swine! Still not thickening. Let me just find out why. Let's come back in. He's going to give me another random complaint somewhere now, isn't it? I just know it. Is it because of that? Is that face still there? That's why, because that face is still there. Okay. Okay, now what I need to do is just get rid of that face again, because that face is still there. Yeah, what a little sneaky one this has been. And again, this is the exact same thing that you're going to face through the assignment, and it is just patience, slowly working through where you know there is problematic issues with the system, and it's all about sodding circles. You think that everything's going to be fine, and then you look and go, no, that doesn't work because of this, this, or this. So I've pulled that surface, just need to check again. Is it going to give me anything that I'm after? Is it going to work? Yes, it is. Right, so now that means all this, all this for something like that, but it's all worth the effort. Absolutely all worth the effort. So let me just double check that I'm all. So I'm just going to come back to here. I'm going to edit on this sketch. Basically, it's not happy because I've done that. Just remove that out. The only reason I'm doing that is because it lost its relation because I've changed so much. I've been going backwards and forwards, figuring out exactly what's going on. The sketch is still the same. So just to recap, the flow wasn't passing all the way through. What it was doing is creating a twist or a knot. Those of you who are very CAD savvy will know that this is about knots. And when you get knots on round surfaces, it's like a super problem. Nothing's going to function as you want it to. I'll quickly just fix this, just because it will annoy the crap out of me if we don't get this done and dusted. And so I'll go up to next, again, doing the same. Going to go about 5 degrees and it's going outwards. Okay, I am going to move quickly on this because I know that we're running close to time, and I'm glad that solved it though. As annoying as it was, there is some key things still about this. This system's ability as far as handling circles, as much as that was problematic, it is still very good. The aspect of what this system can do is very, very good, and it is really impressive if I'm absolutely honest. Let me just quickly check that that dimension is correct, 'cause I'm sure that was something like 12.5. It is 12.5, so I'm going to drop that to 12.5, then click OK. And I know what's going to happen now. I'm going to get all this together and go, still not thickening! Shit! So what I'll do now is bring that thickening in, and I'm going to highlight the whole thing. I almost need a drum roll. And click OK. You almost want to get up and cheer. So there we go. We got that thickened part, and it was coming from, just to recap, it was coming from a small needle surface stuck at the edge of here, and it was coming from the fillet that passed across to here. When it hit here, it created a knot. Now the interesting thing is here, you can almost see that it's doubled. What Inventor will do is it will store it in two formats. The solid is predominantly controlled by the surface. So if I just, if I now make this non-visible, now this is in solid form. I can take this out, I can run this in heat, I can run this in pretty much what I want, and I can do all sorts with it. If I want to take it back to look at it in a composite format, I can actually come back to the surface, turn that back off, and then I can go back onto my surface, take that out, and I can now start to use these shells as something else. This is a bit different in comparison to Dassault. Dassault do say, look, you've got one or the other, which way you're going. With Autodesk, they say, look, we'll give you both, but you predominantly focus on the main one itself. So in essence, you do end up with two, but they are directly related. You do any geometry, you do any modelling in the solid geometry, only the solid geometry would be edited. The surface still would hold its own geometric identifiers. If you wanted to change it, you do just go back and you change the suit. But yeah, the swine, that one really caught me off guard again. But I'm glad we could solve it. Right, so we're on 10 to 4 now. I did not want to run through anything else. What I'm going to do is I'm going to do base part, derived part I should say. I'm going to do that as an extra video, just for anybody who's interested in it. If there is any burning questions about this, you're more than welcome to ask. The key things in this is your assignments. If you are motorsports, your assignment has changed. If you are aerospace, your assignment has changed. If you're mechanical or CAE, again, your assignment has changed this year. So please, please do not start it, because it will all be lost in vain. I mean, saying that, it'd be good practice. Either way. But please keep that in mind. Yes, but this is advanced and basic lofting. The advanced side, I've got a real pain in the backside then. But always keep in mind, if you have curves, if you have sophisticated surfaces, This what we faced here will be just a highlight as the problems that emerge. There is no way of fixing it. There is no magic wand as such to get this working straight out right. What you've got to do is just be vigilant as to things that are going on. Like me then, all I was trying to do is to particularly pick out the key problematic areas. Now I knew about the geometric interface, so I knew that everywhere where there was a curve, a key curve, there was going to be something going on. That's why I targeted this loft here, and I also started to target the fillets. One of them had to be responsible. When I was going to thicken, you'll notice that a red marker came up saying this particular area is problematic. That is golden. Not all systems do that. Some systems just say, sorry, don't work. And it's frustrating, really, really annoying. But it is just something to keep in mind. Again, I hope you guys have found that a benefit. For those of you who are incredibly nerdy and like myself, if you noticed from the difference between how Inventor and SolidWorks, for me, if this was a boxing match, for me Inventor won that one, because its ability of dissecting circles is very impressive, really, really impressive. But on the other hand, I do find Dassault a bit more intuitive when it comes to creating guides of flows between lofting. So but that's my opinion. It's only my opinion. So what I'm going to do is stop recording. Let me just stop recording. Let me just find the actual recording. There we go. So